All right, welcome back, Biology 100 students. Today we're going to continue our conversation about the reproductive system. We're going to look at the female reproductive system, which is quite a bit more complex than the male reproductive system. Okay, so what are the functions of the female reproductive system? Well, firstly, just like in males, we have to produce gametes. In this case, the gametes are called ova or eggs. We also have to produce hormones, and the hormones we're going to produce are things like estrogen, which helps to maintain secondary sex characteristics. We also have progesterone, which helps to maintain the uterine lining in anticipation of having an embryo implant there. Now, the also important point is the female reproductive system is the site of intromission. That is, the penis is inserted into the vagina. It has to secrete mucus for various reasons. And most importantly, it has to gestate and nurture the fetus. This is something that the male reproductive system does not have to do at all. That's why it's a lot simpler, the male system, than the females. The female system has to not only produce the eggs, it has to ovulate the eggs, and then it has to have a place for the next 9 months for those eggs to develop and gestate and give them nutrition through the placenta. So it's a very, very complex anatomical apparatus. Okay, finally, we also have to deliver the fetus, and then even once the fetus is born, we have to provide nutrition in the form of breast milk. So female reproductive system, very complex. All right, let's go on to talk about the female reproductive anatomy. And this includes the ovaries, the fallopian tubes, the uterus, the vagina, etc. Okay, let's start out with the ovaries. The ovaries are the female gonads. They are suspended inside the body cavity, not in a scrotum like they are in males. And these are the organs that produce these haploid oocytes, and they're homologous to testes, again, the same kind of tissue, and they're anchored up there in the body cavity by various ligaments. If we take a look at the inside of an ovary, what you're going to see firstly is there's various stage follicles. A follicle is an egg that is surrounded by this epithelial layer of cells, and these cells are important because as the egg grows and develops, these cells are going to produce estrogens, and later on, after ovulation, they will produce progesterone. So you can see up top there, if I can draw on here, okay, that is a primary follicle. Under the direction of FSH, or follicle stimulating hormone, that follicle is going to grow. And as it grows, it gets more follicular cells. I can't write FSH. And as it gets more follicular cells, those follicular cells start secreting estrogens. So estrogens will be coming out of here, okay, and going to other areas of the body. And that's important for various reasons, which we'll talk about. Eventually, we get something called an antral follicle. And this is just a follicle that's ready to be ovulated. It has this big fluid-filled cavity. And then under the direction of LH, or luteinizing hormone, that antral follicle is going to rupture. And what comes out of that antral follicle is our oocyte. So there you can see right down here is our oocyte, boop. And then that oocyte is then going to travel through the fallopian tube. Meanwhile, the ovarian cells that are left over, the follicular cells, become something called the corpus luteum. And corpus luteum, or white body, is important because it secretes progesterone. And I'm just going to put a P right there. So progesterone will be important for maintaining the uterine lining. Literally, it means go gestation. Okay, before we talk about something called oogenesis, I just want to give you a shout out. There used to be a boutique up on the North Shore, which sadly has now closed, and it was called oogenesis. And as a reproductive biologist of fishes, I thought this was so cool because it's the name for the process of making oocytes. And they also had some really cool local clothing, but unfortunately, it has gone out of business. So when we talk about oogenesis, I'm talking about the process, the meiotic process of taking something that's a diploid cell, like an oogonium, and making haploid cells like we have with eggs. Now, the difference here between spermatogenesis and oogenesis is that for spermatogonium, we had 2 sets of divisions and eventually got 4 sperm cells, each which were genetically different. In the egg, we don't really get 4 functional egg cells out of one oogonium. And there's various reasons for that because the divisions are unequal. The first division we have there produces a bigger cell, and then it produces a much smaller cell, which is called a polar body. And usually the polar bodies are not viable. So a big picture here is that for each round of meiosis in oogenesis, at the end of it, we only get 1 functional secondary oocyte. And that's the one that has to be fertilized. Okay, now let's talk about the fallopian tube. So the eggs are produced inside the ovary. The ovary is where the eggs are manufactured, or at least where they develop, and then they are ovulated from that ovary. They enter the fallopian tube through a funnel-like structure called the infundibulum, and so that's what you can see right up here is the infundibulum. Okay, once we're in the fallopian tube, on our way to the uterus, this is actually where the fertilization usually takes place, in the first third of the fallopian tube, because the sperm are coming up this way and then the eggs going down that way, and this is where fertilization has to happen in order for implantation in order to occur. So if we don't have fertilization, if the egg makes it all the way down to the end, even if the sperm reach it by then, it's not going to have time to develop the structures to implant in the uterus. So successful fertilization has to happen in the fallopian tube. Okay, while we're on the subject of the fallopian tube, we're going to talk about some methods of birth control, and this one is a fairly permanent one you've probably heard of called tubal ligation. So ligation means that we're tying off the ends of the fallopian tube. In some cases, we're cauterizing them or burning them. Some cases, we're just ligating them and then cutting them. Anyway, we're trying to prevent sperm from getting the egg and the eggs from getting from the sperm. And again, this is not a temporary thing. It's something when you've said, I've had enough kids, I don't want to have any more kids, let's get that tubal ligation. It can be reversed in some circumstances, but it's not 100%. When you do that surgery in there, you create a little scar tissue. And so even if you do reconnect those tubes, it's not always going to restore the fertility. All right, so let's go on and talk about the uterus. The uterus, again, is something that guys have nothing like in their bodies because the uterus is a place where we are gestating and nourishing that developing offspring for the next 9 months. So it's where we have implantation of our embryo, development of that embryo into a fetus, and where we're supplying that embryo and later fetus with nutrition through this miraculous organ called a placenta. All right, while we're on the subject of the uterus, we need to talk about the root word hystra. Hystra here means uterus, and hysterectomy means removal of the uterus. You might say, why would you want to remove the uterus? Well, this is something more than birth control. Okay, if you want to do birth control, you ligate the ligate the fallopian tubes. Usually you do a hysterectomy because of a medical condition. Either somebody has pelvic inflammatory disease or endometriosis, something that's very, very uncomfortable. You've tried to treat it in several different ways, and it's just not treatable, so you're going to do some sort of hysterectomy. So we can do what we call a partial hysterectomy, where we just remove the top part of the uterus. We leave the cervix intact. We do a total hysterectomy, where we remove the majority of the uterus, and then something called a radical hysterectomy, which is never good, and that's where you're removing both the uterus, the fallopian tubes, and the ovaries. And this is going to put this person into menopause right away. So that would be a very radical procedure and probably one that would not be very pleasant. Okay, so the vagina is between the cervix, which is this narrow opening to the uterus right there. It's between the cervix and the outside of the body. So the vagina is the site where the penis enters during sexual intercourse. It's the passageway for sperm and also menses, which is the byproduct of menstruation. And it's the lower part of the birth canal. Okay, now we're going to talk about the female external genitalia, otherwise known as the vulva. And now you'd be surprised how many people think they know it, but they don't actually. So my wife used to teach human sexuality at UH Manoa, and each semester she would begin by passing out these little sheets where you just had to label what all the parts were of the guys and the girls, and everybody would snicker and say, oh gosh, how could you not know this? And well, a lot of people don't know the proper names for things. So this is important that we learn the proper names. So again, the external genitalia of the female is the vulva, and it consists of the mons pubis right there, which is sort of literally means fat mountain or mountain in the pubis, and it is an area that's underlined by fatty tissue. Okay, we have the clitoris right here, which is very important. Lots of nerve endings in the clitoris, and it's important for female sexual stimulation and arousal. It's homologous, meaning it's made of the same tissue as the glans penis was in males, and both of those, the clitoris and glans penis, are important for sexual arousal. Okay, below that we have the urethral opening, so that's where the urinary bladder empties through the urethra. Now the interesting thing about females and males is that females have a much shorter urethra and so are much more prone to bladder and urinary infections. Okay, below that we have, of course, the vagina, and then we have the labia minora and labia majora. These are the lips right there, and lots of nerve endings in there. And then we have this area between the anus and the vulva called the perineum. So perineum is just another area of nerve-rich area in there. And of course, we have the anus, which is part of the excretory system. All right, we are going to say something about mammary glands. Now, technically, the mammary glands are not part of the reproductive system. They're actually part of the integumentary system. And that means they're derived from skin, and that the mammary glands themselves, the alveoli in there, are modified, well, kind of sweat glands. So the breast milk is kind of like a modified sweat that we're secreting in order to provide nourishment for the newborn in there. So that milk is made in something called alveolar cells. And then that milk is stored in lactiferous sinuses, and those sinuses are lined with smooth muscle so that when we produce oxytocin, that will cause that milk to be let down through the nipple. And so two hormones are important here. Prolactin, which helps to stimulate milk production. It literally means go milk. And then the other one is oxytocin, and oxytocin is important for the expression of the breast milk. So both of those hormones are important to the mammary glands. Okay, now we're going to talk about the female reproductive cycle. And the female reproductive cycle is more complex than the male cycle. Males don't really have a cycle, they're just always on. Females have a 28-day cycle, and it's governed by what's going on in the ovaries. So we have the ovarian cycle, and the ovarian cycle is determining what's going on in the uterus, and that's the uterine cycle. And remember, who is in charge of the ovaries? If you said the hypothalamus and pituitary, you are correct. Those parts of the endocrine system are running our ovaries through the production of FSH and LH. Okay, so let's start at the top here. We have our hypothalamus. Hypothalamus in the brain secretes GnRH, stands for gonadotropin releasing hormone, and GnRH travels to the anterior pituitary, which secretes FSH and LH. Now, FSH is important because that stimulates the follicles in the ovary to grow. It literally means follicle stimulating hormone. And remember, a follicle is just another fancy name for an egg and its covering of follicular cells. Okay, so once we have that stimulation of the follicle and the follicle is growing, the follicles themselves will produce estrogens. There's lots of different types of estrogens. We're just going to call them estrogen. Now, estrogen is important for female secondary sex characteristics. You know, fat deposition in the buttocks, the thighs, the breasts, etc. It's also important for building strong bones. So we'll talk about in a little while about what happens during menopause and when the estrogen levels decrease. One of the side effects we can get is greater bone loss. So estrogen is important for bone deposition. Estrogen also helps to lower cholesterol, gives you really nice skin and hair and stuff like that. Okay, LH is another hormone that's important. It comes again from our pituitary gland, and it helps to stimulate ovulation. It takes our follicle, our antral follicle, and turns it into something called a corpus luteum. And that corpus luteum is basically the shell of the egg. The egg is gone now. It's in the fallopian tube. But that leftover cells there, the corpus luteum, will produce something called progesterone. Now, progesterone, again, means go, gestation. And it's sitting there to basically enhance what's going on in the uterus. It helps to maintain the uterine lining in anticipation of having a fertilized egg implant there and become an embryo. Okay, so the ovarian cycle, again, is run by what's going on in the brain, the hypothalamus, the pituitary. The ovarian cycle is a 28-day cycle that's divided into 3 phases. We have at first the follicular phase, we have ovulation, which is an instantaneous event, and then we have the luteal phase. Okay, so follicular phase is days 1 through 14, and what's happening here is our FSH from our pituitary is stimulating our follicles, and again, follicle is just an egg with a cell surrounding it. FSH is stimulating those follicles to grow, and as they grow, they are producing, that's right, estrogen. So estrogens are really important. Okay, now around day 14, we're going to have ovulation. Now ovulation happens because we have lots of LH. We have this surge in luteinizing hormone from our anterior pituitary, and it causes the follicle, which you can see is this big sac of cells. That's the actual whole follicle, and right in the middle there is the egg itself. So under the direction of LH, this follicle ruptures, sending the egg into the fallopian tube, and what's left behind, this thing right here, eventually will become a corpus luteum. So we're going to talk about that in the next page. Okay, so after ovulation, the egg is on its merry way down the fallopian tube. We're at day 14 to day 28. So this is the luteal phase, and it's named because of the corpus luteum. The corpus luteum is that leftover sac of cells that's hanging out in the ovary, and its job is now to secrete mainly progesterone. And progesterone is important for maintaining that uterine lining, again, in anticipation of having an embryo implant there and then go through the whole gestation process. Now, eventually, if we don't have implantation of a fertilized egg, we're going to convert that corpus luteum into a corpus albicans. The corpus albicans stops secreting progesterone, and when that happens, menstruation occurs. Okay, so here is just a review of what we talked about. The first 14 days were the follicular phase, that under the direction of FSH from the pituitary, follicle stimulating hormone, our follicles, or our eggs and their surrounding coverings, are growing. And as they grow, they secrete estrogens. But around day 14, a surge in LH from the pituitary is going to stimulate ovulation. So our egg leaves the ovary and then enters the fallopian tube, and what's left over becomes this corpus luteum, and the corpus luteum secretes progesterone. Progesterone is important for maintaining the uterine lining in anticipation of having that embryo or fertilized egg basically implant there so we can form eventually a placenta or something like that. But if we don't have implantation within a certain amount of time, eventually the corpus luteum stops producing progesterone and it becomes a corpus albicans. When that happens, we have no more progesterone, and when we have no more progesterone, we're going to have menstruation. Okay, so here you can see basically the hormone profiles in there. I'm not going to test you on this, but what I want you to see is that the FSH is what triggers everything initially. FSH stimulates the follicles to grow, and then as the follicles grow, their production of estrogen is going to steadily increase. And then right around day 14, we have that surge in LH, which causes ovulation. The egg leaves the follicle, enters the fallopian tube, and now what's left behind is that corpus luteum, and that corpus luteum is going to increase secretion of progesterone, which once again is important for maintaining the uterine lining. Okay, the uterine phase. We said before that the brain controls the ovary controls the uterus. So the uterus is going to basically take its cues from what's going on in the ovary. We have basically 4 different phases there. We have a menstrual phase, a proliferative phase, ovulation, of course, which correlated with our ovarian phase, and we also have something called the secretory phase. We're just going to go through these very briefly. Okay, so let's start at days 1 through 5 here. We're now in the menstrual phase. At the end of the last phase, we started with our corpus albicans, which no longer secretes progesterone, and when that happens, we have menstruation. Without progesterone, the uterine lining will break down, and it is shed through the act of menstruation. Okay, so this is coinciding with the first part of the follicular phase in the ovarian cycle. Okay, the next few days there, going from days about 4 to 14, we're now in the proliferative phase. So to proliferate means to build up. So the uterine lining is building up under the direction of estrogens. Where were the estrogens coming from? Well, they were coming from those developing follicles, right? So estrogen helps the uterine lining to build up. Okay, and then we had, at some point, right in the middle there, we had ovulation, right? Ovulation was triggered by a surge in LH, and that's something that happened in the ovary. But after that ovulation happens, that leftover sac of cells is called our corpus luteum, and it secretes estrogen along with a lot of progesterone. And that progesterone is important for this secretory phase there. We get these large endometrial glands that secrete mucus, we secrete glycogen, and basically we're getting ready for the possibility that we're going to have a fertilized egg implant on the endometrium. Okay, so what happens? If fertilization occurs within this time window, there's only a few days of a time window, the corpus luteum will be maintained by something called human chorionic gonadotropin. And this is going to prevent the uterus from breaking down because this basically corpus luteum will continue to produce progesterone and continue to maintain the uterine lining. Now, HCG is something you've probably heard of before. This is what we use to test for pregnancy in a typically P-stick pregnancy test. We're looking for something called human chorionic gonadotropin, but it doesn't really show up in detectable levels until about 7 to sometimes 10 days, depending on the test. So, you can be pregnant for the first 3 or 4 days and the test may come back negative. Okay, now what happens if fertilization doesn't occur in this particular time window? Well, if no fertilization occurs, that corpus luteum is going to break down, become a corpus albicans. We're not going to have progesterone anymore. Without progesterone, what do we have? We have menstruation, and the whole cycle starts all over again. Okay, now let's talk a little bit about female sexual response. Just like males, females enjoy sex. If we didn't enjoy sex, we wouldn't have sex. If we didn't have sex, there wouldn't be people. So it's just that simple. So unlike males who have a refractory period, that is a time where they can't have another orgasm or they can't get an erection, females don't necessarily have that. They can experience multiple orgasms back to back to back. Female libido is different than male libido in that we think that the androgens produced by the adrenal cortex are more important in females than they are in males. Okay, so there are 4 phases of the female sexual response, and they parallel the male phases. But here, a lot of what's going on is inside the body. Now, obviously, the genitalia, the external genitalia, the vulva, they're becoming engorged with blood, just like in males. There's even some erectile tissue in there. But a lot of what's going on is actually inside the body, so we aren't able to see it unless we use an ultrasound. What you'll notice first is during the excitement phase, the uterus basically starts to stand up on end, and it will pulsate a little bit, and during orgasm it will pulse, and then it will eventually go back to its normal size and shape. So the uterus does move around, as well as the clitoris also becomes engorged as well. So how do we figure out about male and female sexual response? Well, for a long time, we sent people surveys and stuff like that. We had Masters and Johnson that did some pretty cool work on reproductive anatomy and reproductive behavior in people. But it wasn't until we started putting people inside an MRI during sexual intercourse that we actually see what's going on in there. And ironically, this became doable, not when we had the MRI, because we've had those for a long time, but after we got medications like Viagra, because it enabled a guy to keep an erection for a lot longer, and you have to be in these MRIs for a long time to take a picture. So what we can see there is we can see the picture, the penis right there, the testes are right there, okay, and then right along here is the spine, okay, and this, if I'm looking correctly, that should be the uterus. And then the urinary bladder, if I've got my anatomy correct, should be right about there. Okay, so it's pretty interesting to see, what the human looks like in sagittal section and what's going on in sexual response in an MRI machine. So there must have been some very brave souls that participated in that experiment. Okay, so we're almost done with our discussion of the human reproductive system, but before any discussion of the human reproductive system can be complete, you need to talk about the STIs, or sexually transmitted infections. These are things like HIV that you've heard about before, chlamydia, gonorrhea, syphilis, all kinds of fun diseases you do not want to get. Now, we're not going to talk about many of them, but we will talk about 1 or 2. The first one I want to talk about is something called genital warts, and genital warts is caused by something called the human papillomavirus, HPV. Now, not only does HPV cause these unsightly, basically warts on the outside of the skin, the genitalia, etc., but we've now linked about 80% of our cases of invasive cervical cancer to HPV. So having this virus is pretty strong indicator you may possibly come down with cervical cancer. So we want to prevent this as much as possible. Now, why do I have a turtle up there? You might ask yourself, well, this is a different type of papillomavirus that affects the sea turtles here in Hawaii, and it cannot spread to people, so don't worry about that. But it can be very devastating for these animals, and it would be great if we had a vaccine to treat this. And although we don't have a vaccine for the turtles yet, we do have a vaccine for people. So this vaccine is called Gardasil, and it is a human papillomavirus vaccine, and it's very effective in preventing HPV infections. And if we prevent those infections, we can prevent one of the major causes of cervical cancer in women. Now, the interesting thing about this vaccine is it has to be taken by people before they're sexually active. We're actually looking at giving it to male children now as well as females. So this means we need to start asking parents about, hey, do you want to give your daughters Gardasil at least by the ages of 11 or 12, even as early as 9? Because if they don't have it before they're sexually active, they can get that infection very, very quickly. So it can be an uncomfortable question to have with the parents or conversation to talk to them about their 11 or 12-year-old daughter when you don't think about them that way as being adults yet, of having this vaccine to help prevent cervical cancer. Okay, another viral infection is something called genital herpes. You've probably heard about herpes before. It's caused by a herpes simplex 2 virus, and this is something that can cause flare-ups that eventually go away and come back and go away and come back and go away. Some people can be asymptomatic and not have flare-ups, but can still spread the disease. It's very difficult to treat. You're not really going to get rid of it. We can use antivirals there, like acyclovir, to reduce the intensity of flare-ups. Okay, now we're going to talk about birth control measures, and this is hopefully something we're going to do in class together. I want you to go onto the CDC website and figure out which birth control measures are most effective. And there's 2 different measures of effectiveness. There's a measurement like as used by the label and also as typically used. Because if you look at as typically used, people make mistakes. Now, condoms are about 90% effective, give or take. They break about 10% of the time, which is scary. Intrauterine devices, about 99% effective. Really great. Once you put them in, they don't fall out. Oral contraceptives, are something that can be very effective if used as directed, but again, it's a pill you have to take every day, and if you forget, the effectiveness goes down. So hopefully this will be a fun activity we can do in class, is go on the CDC website and talk about the pros and cons of different types of birth control measures. Okay, now we're going to end up talking about something called menopause, which is something that affects females and does not affect males. So menopause happens when the female no longer has menstruation for a period of 1 year. Now, eventually, the sort of reproductive system shuts down, and when that happens, we have a precipitous drop in estrogens and progesterone, and this has wide-ranging effects all over the body. Okay, so menopause was this point where we stop menstruating, and when that occurs, we're also going to stop producing estrogen. So estrogen levels decline very precipitously, and this leads to a couple of uncomfortable situations. Firstly, we're going to have some atrophy of the breast tissue, atrophy of some of the reproductive organs. We can also have some mood changes. People can become more irritable. You get these hot flashes that are very uncomfortable, and gradual thinning of the skin, hair loss, but also, very importantly, bone loss. Because one of the things that estrogen did is it kept our osteoclasts in check. Remember when we talked about bones, we said osteoclasts are these little cells that kind of eat bone. And so normally we have this estrogen there that's being like, hey, chill out, man, chill out. But when the estrogen goes away, the osteoclasts become much more active, and we start to have loss of bone density. And we see this more in females than in males because males don't really have anything like menopause. The other thing that can happen with menopause is we have increased total blood cholesterol levels and falling HDLs, and this can put females at greater risk for heart disease. Okay, so one of the ways that we used to treat menopause or the symptoms of menopause was something called hormone replacement therapy, or HRT. We still do it to a limited extent today, but not nearly as much. So HRT basically involved giving women back the estrogens that they were now missing. And where did those estrogens came from? Well, initially they came from horses, and we would basically have these farms where horses were kept pregnant all the time, and they would lose a lot of estrogen in the urine, so we would actually collect that urine and then make a pill called Premarin, which was basically a contraction of pregnant mare urine. That's where it came from. And it was a way to alleviate some of the symptoms associated with the hot flashes and things like that. Now, we now know that some of the side effects of these pills, at least in the long term, can be increased cardiovascular disease. Some types of cancer rates might go up as well. So we use them a lot more sparingly than we used to.